Okay, so forgive the glass table. This is Johnny again. So these are our test jigs, okay? And I don't have very many of them because, well, they melt. That's their job. We go through a lot of these during the engineering and testing process. But you can see that they're labeled, and what the labeling means are the different conditions that we put the cables through. For example, this is 3.1 millimeter. So that means that this has a 3.1 millimeter gap in the, well, these are the ground wires, but you can barely see. So the ground wires are actually where they're supposed to be, and you can barely see the 12 volt. It almost looks like they're not there. That's because they're pulled back 3.1 millimeters from where they're supposed to be. And you can see how we do that is we just pull the terminals back here 3.1 millimeters and then solder them down. So what this emulates is 3.1 millimeters, your connector's not plugged in, and there's a 3.1 millimeter gap. And then, you know, we've got a 3 millimeter, 3 millimeter, and then we have some here, like this one says 3 pin. What that means is, as you can see here, there's only 3 12 volt pins. So this is actually like missing pins here, missing 3 pins. Or I'm sorry, missing 3 pins. Okay, I was right. This one's 4 pin. So this one's missing 2 pins and has 4 pin. I actually have one that's, or I usually have one that's 2 pins, so it's missing 4 pins. Obviously I don't have that one here because that is the one that melts the quickest. So that is the one that gets damaged the quickest and they go through the most. So I don't have any more left. They're all gone. Anyway, so I prevent myself from damaging graphics cards by using this. And that's why these all look so funny, like on a little PCB with holes on it. You screw the connector, or the jig, sorry, onto this board here with these little spacers. Yes, they're just motherboard standoffs. Screw it on here, and then you have this little about 3 or 4 inch extension cable, okay? Yeah, like 150 millimeters. And this is going to go to the GPU on this side, and then your test cable, the one that you're testing, that you're creating the gap with, plugs into here. So what's going to happen is, instead of ruining your $3,000 graphics card with this melting, the cable that's plugged into here and this connector melts instead. So we don't end up destroying a bunch of graphics card, we just end up destroying a bunch of these pieces and a bunch of cables. So that's how we end up testing these things without, going through tons and tons of cables. So just thought you guys would think that was pretty cool. So yeah, like I said, so here's one. VGA means that goes to the graphics card, 3.1 millimeter. And as you can see, if I can get into the light just right, there's a 3.1 millimeter gap on those 12 volt pins. See, that's normal. That's 3.1 millimeter gap. So that means this, see, that says VGA, so that means this is actually plugged in backwards. Somebody messed this one up. I wonder if they actually tried to use it or not. So yeah, which doesn't matter anyway because this one's normal. Use this as a baseline. So you plug the normal one in first, you get all your baseline temperatures, run it through about 24 hours of testing with whatever benchmark. Log all those in the data logger, then swap this out for your 2 pin, 3 pin, 4 pin, 2 millimeter, 3 millimeter, 3.1 millimeter, all the different ones. Do that for each jig, and you plot new new temperatures on your data logger, and you see what kind of temperatures you get. And that's basically the routine that we did throughout the whole process of developing the cable, to figure out where we want the thermal switch, what temperature to set the thermal switch at, and also just in general to see if the thermal switch would work. So so that's it. So hope you enjoyed.